Let's talk now about what is the fabric control plane. If you want a short answer to the question, what is the fabric control plane? Lisp. Lisp means Locator ID Separation Protocol. It is defined in the set of RFCs. That means that this is a standard. And Lisp will help me to locate the destination for the tunnels that I will be creating in the overlay. Remember that within my fabric, the overlay is in charge of creating these tunnels. And I'm going to use VXLAN in order to move one Ethernet frame from one point of my fabric to another point of my fabric. But the question arises for every single tunnel that I'm going to create, what is the destination IP address that I'm going to use to create this tunnel? And that is where Lisp kicks in. Lisp will tell me what is the destination IP address that I'm going to use to build these VXLAN tunnels. If you want a longer answer, you can continue watching because we're going to talk about more details about how Lisp actually works. Remember that Lisp is going to create mappings between RLOCs and endpoints IDs. So every single device that I'm going to connect to my fabric, it will be identified by an endpoint ID that will be these devices' IP address and MAC address, regardless of whether this device is getting connected through a wire or it is a wireless device. I'm going to use these devices' IP address and MAC addresses to identify it. And I'm going to use the loopback IP addresses that are configured in my network devices as my RLOCs. So for instance, if this device that I'm connecting here had the IP address 1.1.1.2 and this loopback IP address was 10.0.0.1, then I will create a mapping between the IP address 1.1.2 to the RLOC 10.0.0.1. And if this device for some reason stopped being connected here and I connected this device to this other network device that had the loopback 10.0.0.3, then I will have to update my mapping. So IP address 10.1.1.1.2 will be mapped now to the RLOC 10.0.0.3. So this mapping is dynamic and will follow how the end device is getting connected to different network devices within my fabric. But it is not only that. Remember that within my fabric, I can define virtual networks. So these virtual networks are identified by a particular number. So my actual Lisp mappings within my fabric will be an endpoint ID. Remember that this can be an IP address and a MAC address. An RLOC. Remember that the RLOCs are actually loopbacks that belongs to my network devices and an instance IDs. So this instance ID will correspond to VXLAN layer 3 VNIDs or layer 2 VNIDs. And let's talk a bit about why do we actually need Lisp. So remember that in traditional networks, I will have several databases. I will have, for instance, a MAC address table that will provide me location, layer 2 location for my end devices, and transport, layer 2 transport for this layer 2 part of my traditional network. I will also use an ARP table that will provide me with mapping between IP addresses and MAC addresses. And it will help me because traditional network will use layer 3 technology and layer 2 technology. And then I will have a really big routing table because it will help me locate in the layer 3 where my devices exist, and it will also help me transport packets in the layer 3 part of my traditional network. So this was, if you think about it, we are mixing transport with location and mapping between IP addresses and MAC addresses in traditional networks. So I'm not going to use this paradigm anymore. I'm now going to have an underlay, and within that, in this underlay, I'm going to create a really small routing table that will only be including loopbacks and interconnections within the underlay, so I can transport data from point A to point B. So this is really small routing table in the underlay will help me only to transport my data from point A to point B. And I will have another database that will be my host tracking database that my control nodes will create in order to have mapping between IP addresses and MAC addresses. And I will also have a mapping between endpoints IDs and router locators. So I will have location information here, and I'm going to use Lisp for that. So I'm going to leave the transportation information live in the underlay, so I can move just traffic from this point to this other point, or from this point to this other point, or from this point to this point. And I'm going to leave the location information in the host tracking database in the overlay. So that is why we are separating activities that will remain in the underlay and activities that will belong to the overlay. Let's talk now about more details about how Lisp works. Remember that we use a map server. The map server is in charge of creating and maintaining the host tracking database. I can have more than one map server in order to have high availability. And the way that these map servers will create and update their databases is by receiving map register message from end devices for my network devices. So these network devices should make sure to send map register message to every single map server that is working within the fabric, because I need to maintain these databases in sync. And the way that I'm going to do so or achieve that is by repeating this map register message to every single map server in my network. I will also have map resolvers. The map resolvers are not in charge of creating or maintaining the host tracking databases. They will be only be querying these databases. So the map resolvers will be querying or extracting information from the host tracking databases. If I put these two activities in the same device, I'm going to create an MSMR of map server map resolver. In the case of Cisco's Fabric, the control plane node will be my map server map resolver. Uh, Regarding the Lisp terminology, if I have a network device that let me send information from my Lisp domain into an end device, then that network device is known as an egress tunneling router. And if I have a network device that lets me receive information from end devices into my Lisp domain, then that device is known to be an ingress tunneling router, or ITR. If I have a network device that is both an ETR and an ITR, then I will call this device an XTR. Now, if I have a Lisp domain and I have an external network, and I have one device that will let me receive packets from my external network into my Lisp domain, I will call that device a proxy ingress tunneling router. And if I have a network device that lets me send information or packets from my Lisp domain out into an external network, I will call that network device a proxy egress tunneling router, or PETR. And if a network device performs both functions, that means that it is both proxy egress tunneling router and also a proxy ingress tunneling router, then I'm going to call that device a proxy XTR. Remember that my network devices will establish TCP connections in order to communicate with my control nodes. So in this sense, my edge nodes will be sending map register messages over these TCP connections in order to inform the control nodes of new devices getting connected to the network. Now the question here arises, where these edge nodes know, or how these edge nodes know what is the IP address and MAC address that belongs to this device. The edge nodes are able to know that by several means. They can catch the traffic arriving from these devices, for instance, ARP requests. Remember that when a device sends an ARP request, it will inform its IP address and MAC address. So that is one way that the edge node can tell what is the IP address and MAC address that belongs to a device that just got connected to it. Another way will be intercepting DHCP frames. Remember that we have several frames that are part of the DHCP process. The edge node can intercept these frames in order to figure out what is the IP address and MAC address that belongs to this end device, so it can send a map register message to the control nodes. There is an issue here because there are some type of devices that are known as silent devices, that they are not usually sending anything into the network unless they receive a broadcast or a unicast directed to them. So we will have an issue with these silent devices, because if you had silent devices in your network, your edge nodes will not be able to figure out what is the IP address and MAC address of these silent devices. So if you had these, you will need to enable something that is known as flooding. So by enable flooding in a particular VLAN that lives within your fabric, you will be able to send broadcast to these particular silent devices, and this broadcast will probably help these silent devices to answer something into their network, so they can let the edge know what is this silent device IP address and MAC address. This has a penalty because you will be actually sending broadcast on unicast and multicast within the fabric. That is something that we don't really like to do. Flooding is disabled by default on your VLANs that you will be creating in your fabric. So you have to take that into consideration when configuring your VLANs. So this is just a reminder. Remember that list will map RLOCs, endpoint IDs, and instance IDs. And this instance ID will have to map a layer 2 VNID that exists in VXLAN, or a layer 3 VNID. So you can have a layer 2 instance or a layer 3 instance. Layer 2 instance begin with an 8, and layer 3 instances begin with a 4. So this is a summary of your messages. Remember that when you plug in a device into your network, your edge node will send a map register to the control nodes, and the control nodes will have to respond with a map notify. And when an edge node wants to create or build a tunnel in order to send an Ethernet frame from a source to a destination, they will have to figure out what is this other edge node IP address. In order to figure out what is this IP address, they will have to send a map request to the control nodes. And in this case, if everything works correctly, the control nodes will send a map reply with the IP address that belongs to this destination edge node. But if this particular endpoint ID that this edge node is querying for is not located within the host tracking database, then the control node will send a negative map reply. So in that case, this edge node will not be able to locate where is the destination to where this endpoint end device is connected to into the network. In that case, the edge node will send traffic to the default route that exists in the underlay that will usually be received by an external border node. So as a final comment, remember that we are using TCP connections. We're using TCP in order to have a Lisp communications between my border nodes, my control nodes, and Lisp in order to enhance and make Lisp a little bit more efficient. we have something that is known as Lisp enhancements. So in the first releases of the Cisco Fabric, we had something that was known as Lisp / BGP enhancement, where we will run iBGP between my border nodes and my control nodes as an enhancement for Lisp. But in more recent versions of the Cisco Fabric, we are going to run a different enhancement for Lisp that is known as Lisp Pub Sub. So this the Lisp BGP will be an old enhancement to the Lisp protocol, and the new version of this enhancement will be Lisp Pub Sub. That's it.